So anyway, for stochastic interest rate is when we are considering interest rate again. So okay, as the names are just, this is a stochastic interest rate, right? So it means that the interest rate is random. So throughout our, actually throughout high school, even first year and second year, we have only been looking at interest rate as a constant variable, right? So you only have 1%, okay, let's just say maybe you have I% for this many years. Okay, let's say maybe for n years, or maybe sometimes they can try to trick you, and then they say that you are going to have this much interest rate per annum, and then after maybe 5 years, it's going to change to I2 up until some other years. But now, when we're considering the stochastic interest rate, what we mean is that this interest rate is not known, right? You can expect it, like it can have expectation, it can have a distribution. You can see that interest rate is going to be either 1%, 2%, 3%, stuff like that, with this much probability, right? So okay, let's say this is the case, right, for any given year. So, and the interest rate of any given year is going to be different from the other interest rate of the following year. So if you have 2% interest rate this year, next year the interest rate might be 1, 2, or 3 again, and then that following year it might be 2 again, and then 1, and then 3, stuff like that. So it might change. So you don't know how much it's going to be this year. You don't know how it's going to be next year, and the interest rate of this year is not going to change the interest rate of next year. So they are independent. So this property is important when you start to do the proofs. Are we all clear? I will assume we are all clear at the moment. So so I am trying to avoid doing the proofs, but I'm not sure if there's one of you who want me to do the one proof, so that we can see how the interest rate goes. Should I do the proof, or should I just go straight to past papers? Okay. Anyone want me to do one proof? So I think that by this point, actually, we should know a little bit about the proofs. They might be a little bit confusing, but then I think we can just go through past papers, right? So if you want me to do the proof, please don't be shy. So anyway, I am going to move on. So before we can do the past papers, there is something else which is very important in this course. You can rest assured that they will ask you this question. So interest rate can have a distribution, right? We already know, we have learned so many distributions so far. Normal, log normal, uniform, stuff like that. So an interest rate can have a distribution, and the distribution that you can almost rest assured that they will ask is the log normal distribution. Where we see that the interest rate 1 plus I can follow a log normal distribution with parameter mu and sigma squared, right? So they should expect in your test. You should expect this starting. I will almost give you, I am pretty sure that there is like 9% chances that they will ask you a question that says that 1 plus I has a log normal distribution, right? So if 1 plus I has a log normal distribution, there is something else that you should know. That so it simply means that 1 plus I to power n is going to have log normal. This is supposed to be log normal. It's going to be log normal with n mu and sigma squared, right? Distribution, right? So this is, and the ln 1 plus I to power n is going to have a normal distribution, right? I'm going to put this in here. When you find the ln normal distribution, you are going to convert it into a normal distribution. So you're going to have a normal distribution with n. Keep this in mind. So now when we do this chapter, we talk about this again. So we talk about the stochastic interest rate, meaning that interest rate will be different every year. So if you have 1 plus I t, right? So this t is given year, right? So it means that the interest rate for any last interest rate or of the following year or of any other year. So it's going to be 1 plus I. If you are given that 1 plus I has a log normal distribution with mu sigma squared, then ln of 1 plus IT is going to be normal distribution with mu sigma squared. And then again, there's someone who's this is just to emphasize what I again, if you have the sum, I mean the product of 1 plus I is going to be again it's going to be log normal with n. Let's say maybe the t starts from 1 up to n, and mu and sigma squared. The same thing will apply when you put the ln. You are going to have a normal distribution, right? So fine. How do you find these variables? I mean, like, how do you find these parameters mu and sigma, right? So to find them, they will give you information that the expectation of 1 IT is going to be a certain value. Whatever value they give you, let's say maybe they give you 1,06, you can equate this thing to e to power mu plus sigma squared over n. I think I need to write something else. You can also say that 1 plus whether you are given the expectation of this or you are given the expectation of only I, you can actually you can just add 1 and then you can answer your question, right? And then you can equate it into the equation. So this one is not always 0.6, I'll say. example. So anyway, to find, okay, now you have two variables. So it means that you will want two equations. So again, the variance of 1 plus it is going to be equals to variance. I should write variance. It's going to be a variance of it, right? And it's going to be equals to E 2 mu plus sigma squared. This is supposed to be 2, by the way. Sigma squared E sigma squared minus 1. So this is how you find your variables. You're actually going to solve for these things. So again, so we can do past papers. So I got this question from someone. I have no idea why they got the question paper, but I think we can try it. So I am going to give you 8 minutes to read the question and have a head start before we can attempt it together. So anyway, the question wants you to calculate the expected accumulated accumulation in 30 years if 500 rand is invested. So this question say that you have the annual interest rate on a fund, again, on a fund independent and also identical. Each year the distribution of 1 plus I is going to be log normal. 1 plus I is going to be log normal with mu 0.06 and sigma squared sigma squared is 0.01 right on the fund, where I denote the annual interest rate. So the question says here that calculate the expected accumulation after 30 years, right? So they want to find how much is the interest rate after 30 years. So I hope you guys have tried it. So anyway, this is how I would do it. So to find the answer, calculate the expected accumulation after 30 years. So we know that 1 plus I t, I will say the sum of must be t to 1, right? Up to 30 years. Up to 30 years, right? So anyway, it simply means that this is going to have a normal distribution of how much? It's going to have a log normal distribution of 30 times 0.06, 30 times 0.01. So how do you find the answer? So the answer is going to be, so it simply means that the log normal distribution is going to have Oops, there should be a value here. So do you guys actually now this one, okay, it's the first question. So this one, what I want you to know are those proofs again about finding your expectation, right? So in order to find this, you will need to find your I first. So to find the expectation of your I, right? So we already know that to find again, we already know that if we have this, then how can I explain this? This is gonna be okay, let's say maybe you have 500 over here. It's gonna be 500 multiply. Okay, before I can add the 500 rand, I think I can add it later. So I am going to deviate a little bit from here, so that I can come back to the answer easily. So we already know that 1 plus I, the expectation of 1 plus I is going to be 1 plus J. And 1 plus J is going to be what? 1 plus J is going to be equals to E mu plus sigma squared over 2, right? So we are trying to find this J, right? Because you will have to substitute it in your equation. Because this the expectation of this value over here is gonna be equals to what is again it is gonna be equals to 1 plus J to power 30. So you need this J, right? So that's why I say this one needs you to have proved those equations first. So to find how much this J is, you will have to solve this, so you will have to solve this equation first. So we already know that you can say that J is going to be equals to E to power 0.06 plus 0.01 over 2 minus 1. So this is how you will find your interest rate J. J is going to be the expectation of I. And the interest rate is going to be 0.7 something, 0.716. I hope this makes sense. Do you have any questions on finding I? I mean, like on finding your J. By the way, J is going to be equals to I. So J is the expectation of I. So the accumulated value of 500 rand after 30 years is going to be 500 rand 1 plus J to power 30. And the answer $514.34. Any questions so far? You all understand how I got you, or should I repeat this thing? No question. Okay. Okay, I am going to move on then. If there is no question, I assume that it all made sense, hopefully. But then we're gonna have a lot of questions to attempt. So hopefully by the end of the third question, this thing would have made some sense. So the next question says here that calculate the probability that the accumulated that the accumulation of a single investment of R1 will be greater than its expected value 25 years later. So the question says, I will write this thing mathematically. So the question says that calculate the probability that the accumulated value of R1 okay, I think they are talking about this investment up here. Again, the accumulated value of R1 will be greater than its expected value after 25 years. So this is how you are going to write it. So it's going to be 30. T is going to be equals to 1 plus I T, right? So it's going to be greater than than 1 plus J 30. So this is what they are asking you. Again, does it make sense mathematically? I'm like, mathematically, yes, it makes sense. Calculate the probability that the accumulated value of a single investment of R1 will be greater than the expected value after 25 years. Okay, so sorry. This is supposed to be 25 years. So calculate the probability that the accumulated single value of R1 will be greater than its expected, or than its expected. I missed a word here, than it's expected. So this is also supposed to be 25 years. So someone asked me this question later on. So I wrote it, so I made a mistake there. So this is the question, sorry. So how do you find this answer? So we already spoke that so we already said that 1 plus I is gonna have log normal distribution of mu, and mu is gonna be 0.06, and sigma square is gonna be 0.01, right? So this simply means that 1 plus IT, where T is gonna be equals to 1. This thing is also going to have a log normal distribution, right? With N, I already wrote the answers up there. I think it's 1.6 there. I think it's 1, something. 1.8. You'll have 1.8, 1.8, and the sigma square is going to be 0.3. Actually, these ones are wrong because those ones were for 30 years. So you will have 25 times 0.06. It's going to be 1.5. $0.25. So this is how you find the answers, right? So this is the distribution of that thing. So if you put lean both sides, if you put lean, so we have 25 over here, 25. 1 plus I T, you are actually going to have a normal distribution. And it's so much easier to calculate normal distribution. So you'll have 1.5 and 0.25, right? So how do you find this thing? So you already know that this is the equation. To write it down, you will say equals to the probability. You will standardize it. You will have Z greater than lean of 1 plus J, right? To power 25 minus 1.5 over the square root of 0.25. Remember that you should always write you should always write the standard deviation, not the variance, right? you should always write this thing as a standard deviation. So the answer here is written as a variance. You should write here as a standard deviation. So again, so I assume that we know how to find this thing. I mean, like we understand what's happening here. Any questions so far? I will assume there's no question. And then you say equals to, you can just, okay, we already know what our J is, right? We calculated it up there. So I'll just say 1 minus the standard, okay, the standard normal ln of 1 plus the interest rate we got earlier on to the power 25 minus 1,5 over square root of 0,25. Oh, the answer is literally -3. Okay. And then, yeah, this is practically 1, right? So anyway, this is how you find your answer. What is the probability that is going to be? Yes. So none means no question. So I am going to move on to the next question so that we can solidify our understanding. So the first question, want you to derive the formula. So I'm not going to do this question over here. But I am going to do number 2. I mean, like B. So we have 6 minutes. So I am gonna give you a head start. I will give you 30 seconds to try it. Read the question. 1. Okay. I will open my standard number table here. It's almost 1, because I will say 1, but then the answer is going to be 0.99 something, 998 and stuff, which is practically 1. Right? It's going to be 999 actually. This is why it's 1. It says that a small investor decides to invest a lump sum of 20,000 rand at time 0 for 5 years. A constant interest rate I. It is known that 1 plus I has a log normal distribution with mu 1,06 and variance 0,008. What is the probability that the investment will accumulate to more than 35,000 rand in 5 years? So they tell you that 1 mu and sigma squared. So when you have a question like this, it says that the mean is going to be 1,6 and variance is going to be 0,08. So I know that is very tempting to just to want to put these values directly here. So don't put them there. Remember that you will need to calculate it first. We said that the expectation of 1 plus I is going to be equals to E mu plus sigma squared over 2, right? So you only have the expectation of 1 plus I, but then you don't have the variables which you have to put down there, right? So this is my advice for you guys. I know it doesn't really make that much sense at the moment, but then this is my advice to you, is that when you have, when they tell you that the mean of 1 plus I is this value, do not assume that is the mu and it's also the sigma squared. They are not, again, so he's not the mu and it's neither the sigma squared. I hope it makes sense. So if a question comes in a test, in your exam, actually, where they say that a mu and sigma squared, so you can see that in the first question, they literally told you what is the mu and sigma squared. But now they don't tell you what is the mu and what is the sigma squared, right? So you will have to find, again, you will have to calculate them. It's a little bit hard to swallow, but take it from me. Unless, again, another red flag in this question is that if you have, so if they tell you that your mu is going to be greater, again, if they say that the mean is going to be greater than 1, in this case is 1,06, just know that it cannot be the mu of a log normal distribution, which represent an interest rate. Because if that's the case, the interest rate will be more than the 100, and which is which is very unrealistic. So always assume that your 1 plus I, the mean is not the mu and the sigma squared. So anyway, first of all, you will need to find your sigma squared and your mu, and the variance of 1 plus I, which is equals to this, by the way, going to be 1,06. This one is going to be equals to 0,008. It's going to be equals to E sigma squared, E sigma squared minus 1. And then you're going to solve for the mu and sigma squared. So the video is going to cut now. So please rejoin immediately when it cut. We are not done. It's just Zoom, it cuts automatically.